and welcome to today's class. For today, we're looking at pressure. We define pressure, we look at the different units of pressure, we'll solve some problems on pressure, and of course, as usual, we'll treat several Jamb questions on pressure. So before that, let's look at what pressure is, look at its SI units, and then we'll build on from there. Now, for pressure, by definition, pressure can be defined as the force acting per unit area of a surface. That's how we define pressure. Mathematically, pressure is equal to force all over area. So this is a mathematical expression of what pressure is. So you can say pressure P is equal to force F all over area, that's A. Of course, force is measured in Newton and area is measured basically in meter squared. So hence, the SI unit for pressure is Newton per meter squared. So my SI unit is Newton per meter squared or Pascal. Alright, so these are like my SI unit for pressure. Alright, so aside this, there are other units for pressure. Now, some other units of pressure includes, now aside units per meter squared and PA. PA means Pascal. So we have we have PA, or let's say Pascal, that's PA. We have bar, and also we have atmosphere, which is known as ATM. Alright, so these are like, aside units per meter squared, these are other units for pressure. Now, the relationship, just in case you want to do a conversion, the relationship for this is that number one, the relationship between them is that for the first one, we have that 1 Newton per meter squared is equal to 1 Pascal. In other words, Newton per meter squared is the same thing as Pascal, the same thing. So this is my first relationship. Number two, you have that 1 bar is equal to 10 to the power 5 Pascal, which is equal to 10 to the power 5 Newton per meter squared. Alright, so you have this. So this becomes the value of 1 bar. 1 bar is 10 to the power 5 Pascal. Of course, 10 to the power 5 Newton per meter squared. Number 3, we have that 1 atmosphere is equal to 101.325 Newton per meter squared. Alright, so these are like the way we convert the different units of pressure. Aside this, we also have measurement of pressure in pressure head in terms of millimeter mercury, centimeter water, etc. But that's above the Jamb level. So for Jamb level, we'll just focus on these units, which include Pascal, Newton per meter squared, atmosphere, and then bar. So these are like the relationship. We'll take some example and we'll solve problems together. So let's take a first example. This question says, calculate the pressure exerted on the ground by a person weighing 70 kilograms, whose 2 feet covered an area of 400 centimeters squared, full stop. If the man stands on 1 foot, what is the new pressure he exerts on the ground? Alright, so let's get this done. As solution, as usual, our first task would be to list out given parameters. So what are we given there? So given, going through the question again, it says calculate the pressure exerted on the ground by a person weighing, the first I'm giving is the weight of the person, that's W. But observe that the weight is given as 70 kilogram. Of course, kilogram signifies mass. So instead of weight, I'm giving what there? Mass. So hence, I'm giving the mass, not the weight. So I'll just change that to mass. That's M as being 70 kilogram. This is kg. 70 kilogram. Now the next one says, whose 2 feet covered an area, number 2, the area covered by 2 feet, area by 2 feet that's A, is equal to the said 400 cm square. 400 cm square. Sorry, I have this. Alright. So first of all, we have to find the pressure that this man exerts. Now recall that we said force or pressure is equal to force over area. And we said from Newton's second law of motion, we can say force is equal to mass times acceleration times acceleration, or perhaps gravity if you want to. So in this case, let's get force. So first of all, let's get force. We said to recall that force F is equal to mass times gravity, and that's equal to mass is 70 kg times gravity is about 9.8 times the constant. So that means the force is equal to let's see this, 70 times 9.8. Times 9.8, that gives about 686 in Newton. Alright, so that means the weight is 686 Newton. If you want to. Alright, so the weight or its force is 686 Newton. Now, something else, recall that our area is in cm square. So we have to convert from cm square to what? Meter square. Of course, you can still leave the area as cm square and solve. If I solve it this way, my pressure will be measured in Newton per cm square, that's centimeter square. But let's convert to meters. So the question is this, if I'm to convert from centimeters to meters, what do I do? Now, here's what to do. If I record the relation, it says 10 centimeter makes 1 decimeter, 10 decimeter makes 1 meter. So from here to here, it becomes here 1, 2 zeros, cm makes 1 meter. So I'm having this here. If I express this in index form, 100 is 10 to the power 2 centimeters gives you, this one here is 1 meter. But observe, I'm asked to convert between centimeter square and not just centimeter. This is where many persons make mistake. If they want to convert from centimeter square to meter, they go dividing by or multiplying by 100. Please, that's not the case. So my first case has to be getting the proper relation between, observe, cm square, not cm. So if I'm having cm here, centimeter, I want to get cm square. What do? This is simply putting square here, come here to square this. So I have to square both sides. It's that simple. So these two multiply. From the idea of indices, this becomes 10 into these two multiply. 2 times 2 gives you 4, then cm square. So cm square is equal to 1 square is 1, then meter square. This becomes the proper relation between cm squared and meter squared. So we have this. Alright, so this becomes the relationship here. The next task will just be bring this under here. So if 10 to the power 4 cm squared gives you 1 meter squared, how many meters squared, let's call this x, will be equal to what I have here, 400 cm squared. Now this is like the basis of conversion. Alright, for the basis of conversion, first of all, get the relationship between the two parameters you're converting. Next up, bring in what I have here. 400 under cm squared, that's this. Then an unknown value under meter squared. Here we cross multiply. This times this times this. So this times this gives you 10 to the power 4 times x is equal to 400 times 1. That's 400 divided by 10 to the power 4 divided by 10 to the power 4. I will have that x is equal to, let's get the division, 400 divided by 10 to the power 4. That gives you 0.04 meters squared. So you have this. So in other words, to convert from cm squared to meter squared, simply divide this value by 10 to the power 4. That's all. So area given as 400 cm squared is equal to 0.04 meters squared. So I have this. Alright, from here now we can now get the pressure exerted by the man's feet. Alright, so from here recall that we said pressure is equal to force all over area. So have that pressure is equal to force, or which is in this case like I said weight, that's equal to 686 all over area, which we have successfully converted to meter squared as 0.04, and that's equal to 686 over 0.04. That's about 17150. This was in Kelvin all over, this was in meter squared. So I'm having this value. Okay, so then the pressure is equal to 17150 Newton per meter squared, or Pascal, whichever one. So I have, so this is the pressure. You can do the conversion from here. You can take 1, 2, 3. So it becomes 17.15 kilonewton. That's equal to 17.15 from here. If I move 3 times backwards, 1, 2, 3, 17.15 becomes a kilo Newton per meter squared. So I have this, whichever one works. So this is my answer. The second part of that question says something. Second part says, what is the new pressure? We said if the man stands on 1 foot, what is the new pressure he exerts on the ground? If he stands on 1 foot, what is the new pressure he exerts on the ground? The question will now be, which of these parameters does his foot influence? Alright? The parameter that the foot influences is what? The area. Of course, the foot will occupy a particular space on the ground, which is also what there? A particular area of the ground. Alright, so if that's the case there, that means if he stands on his feet, that's both legs there, he will occupy 400 cm squared, which is 0.04 meters squared. What if he now stands on just 1 foot? He will occupy half of this. So hence, standing on 1 foot would mean the area becomes what there? Half of the total value. Of course, it has 2 legs. So if that is true, that means the new area is equal to 0.04 all over 2. That's 0.02 meters squared. It's just a simple logic. He stands on his feet, that's both legs, and he occupies 0.04 meters squared. So if he stands on just 1 leg or a foot, of course, it becomes half of the total area, which is this. But with the weight or the force exerting, the force is exerting, won't it be affected? Of course not. In fact, this is why if you stand on just 1 foot for long, you begin to feel tired. Why? Because the weight that was shared by both feet is now being shared by just 1 foot. So the same force will apply. And it's because of that 1 foot there is carrying the entire weight. That's why if you stand on just 1 foot there, you begin to feel pressure on that leg, becomes tired. So that's the simple analogy there. So in other words, the force will not be affected. So hence, the new pressure is equal to the same force all over the new area. Let's call this A2 if you have to. So all over A2. So the new pressure is equal to the new force. Let's write this there. So equal to the force. The force is 686 all over the new area 0.02. Hence the new pressure. So let's call new pressure. Let's call it P2. Perhaps P2. So we have that P2 is equal to 686 all over 0.02. That's about 34,300 in Newton force all over area meter squared. If you want to convert this to kilonewton, what do we do? From here, move backwards 3 times. 1, 2, 3. So it becomes 34.3 kilonewton per meter squared. Alright, so this is how we solve this question. Alright, so let's take a second example. This question says the pressure exerted by a force on a portion of a wall 0.5 meter square is 100 Pascal, that's PA. Calculate the value of the force if it acts perpendicular to the wall. Alright, solution is. So let's get this done. Solution, as usual, let's start with the parameter. So the first thing that says, calculate the pressure exerted by a force on a portion of the wall 0.5 meter square. So because I'm seeing meter square there, it tells you that that's area. So area is 0.5. Area is 0.5 meter squared. They said the pressure is 100 Pascal. Pascal is pressure. So pressure P is equal to 100 Pascal. Alright, we asked to find what there? Find the what? Calculate the value of the force. Number 3, we asked to find force F equal to unknown. Alright, let's get formulas. So recall that we said pressure is equal to force over area. The pressure here is 100 Pascal is equal to my unknown force all over. The area is 0.5. Observe that all of these are in their basic units. Pascal, we said, is the same thing as 100 Pascal Newton per meter square. In other words, I don't have to convert again. So hence, from here, I'll be having that 100 is equal to force all over 0.5 over 1. Cross multiply force times 1 force equal to 100 times 0.5. Alright, if I work this out, I'll have that force is equal to 100 times 0.5, simply means half of 100, and that's equal to 50 Newton. Hence, the force required is 50 Newton. So this is how I solve this question. Alright, so let's look at our next task, that's pressure in fluids. Alright, what we discussed earlier about pressure was simply pressure for solids. Alright, and that's why if you look at the second example, it said something about a wall. It talked about a wall, which is what? A solid body. What about liquids? Okay, so when we say pressure in fluids, fluids or a fluid is actually a compound term which describes 2 states of matter, and that includes liquids and what? Gases. So the word fluid describes liquids and gases. So if we say pressure in fluids, we mean pressure in what? Liquids and gases. That's the idea. Alright, so if that's so, how do you measure pressure for liquids and gases? Now, here's what you should note. For pressure in liquids and gases, we have a different formula for measuring that. So let's try to derive the formula. First of all, let's recall what we know. Recall that we said pressure is equal to force all over area, as we discussed. But We know that force is equal to mass times gravity. Let me call this my first equation, call this the second equation. So force is equal to mass times gravity. If I put equation 2 into equation 1, what do I have? I have that pressure is equal to force. Force is mass times gravity. So it becomes mass times gravity all over what there? Area. So I've replaced force by what? Mass and gravity. So I have this. You can call this equation 3. Let's recall something about density. What? Density, we say density rho is equal to what there? Mass all over volume. This is mass. This is volume. This is density. If I make mass subject of the formula here, this is all over 1, so it becomes mass times 1. It means that mass is equal to density times volume, gives you density volume. Call this equation 4. If I put 4 into 3, if I put equation 4 into equation 3, it means that pressure P is equal to mass. In place of mass, I'll put the value of what? Density and volume. So density times volume occupies here, so it becomes density times volume, of course, times this one here, gravity all over area. So I have this. This is volume. Volume is measured in meter cube. A is area measured in meter square. I know fully well from my job of mathematics that meter cube is equal to meter square times meters. So it means that volume, which is meter cube, is equal to meter square, which is area, times a particular meter. In this aspect of fluid, we are taking a horizontal length that becomes a height, becomes area times height. That means volume is equal to area times height. H here means height. Alright, so H here means height. So volume is equal to area times height. So but volume is equal to area times height. I've explained why. So meter squared times height, meters, gives you meter cube volume. Alright, if I put this here, it means that pressure, let me call this what? Call this 5. Call this 6. Alright, if I put equation 6 into 5, what do I get? Pressure is equal to density, this times volume. Volume is area times height, so area times height times gravity, this all over area. Nothing has changed, I only replaced volume. So density is here, volume, I replaced it by product of area and height times gravity. That's there. So I have it. From here now, area cancels area. So pressure is equal to rho density times H times G. If I rearrange this, it means that pressure P is equal to rho density times G, gravity times H, height. This becomes the formula for calculating pressure in fluid. Where P, we said, is pressure in Newton per meter square. Rho is equal to density in kilogram per meter cube, because I'm having mass over volume. As we said here, this mass over volume. G is acceleration, ACCL, due to gravity. So ACCL gravity in meter per second squared, and finally H is equal to height. Height is in meters. Alright, so that means to calculate pressure for fluid, multiply the density of the fluid by acceleration due to gravity by the height of the fluid. So this is my formula derivation for pressure in a fluid, whether in liquid or in gas. We'll take some sample problem, we'll solve together, and then we'll look at some Jamb past question on pressure. Alright, so we'll take some questions on pressure in fluids and so on. By the way, we just derived the formula for pressure in fluids as P equal to rho GH. Now, it doesn't necessarily mean you have to go and start cramming the derivation, alright? I would have just given you the formula, but I thought it wise to do the derivation first. So you don't start asking how, alright? But you can, if it's too complex, you can just forego the derivation. But always remember that pressure is equal to force over area in terms of solid, and pressure is equal to density times gravity times height in terms of fluids, that's liquids and gases. Alright, having said that, let's take some examples. So let's look at this example. Example 1 says, calculate the pressure of water at the bottom of a dam 200 meters deep. If the density of water is 1,000 kilograms per meter cube, take gravity to be equal to 10 meters per second squared. Alright, solution is we start given parameter number 1. It says calculate the pressure of water at the bottom of a dam 200 meters deep. And that's what we said when it comes to pressure in fluids. We look at the height. So that means the height from the height of the dam below or downward is what there 200 meters. That's what it said, deep. Alright. So number 1, I'm giving height. H is equal to 200 meters. I have this. What they have said, if the density of water is 1,000, number 2, density of water, so I'm taking rho as 1,000 kilogram per meter cube, and they said gravity G as being 10 meters per second squared. So you have to find the pressure. Now let me say something straight up. The density of water is always a constant, and the value is 1,000 kilogram per meter cube or 1 gram per cm cube. Alright? Don't forget this. 1,000 kilogram per meter cube or 1 gram per cm cube. So in other words, you would not be given a value of density of water that will be anything aside this. So it's always 1,000. So that means whether you're giving density of water or you're not giving, so far as it's water, the density is always what there? 1,000. So please always note this way. Alright, so that's so. We'll have that the pressure, so therefore, this is here. So therefore, the pressure P is equal to rho times G times H. And that's equal to density of water, 1,000, times gravity, 10, times the dam is 200. Alright, so let's get this done. This is equal to, if I multiply all of this, that becomes 2. Simply count number of zeros. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Pressure is measured in Newton per meter squared. So this is my answer. Perhaps I should do some conversion. From here I'm having 1, 2, 3. That's kilo. 1, 2, 3. That's mega. So that's equal to 2 times 10 to the power 1, 2, 3, 4, 5, 6. I have 6 zeros. Newton per meter squared. This value is what is called a mega. So hence I'll have the pressure P is equal to 2 mega. Mega is this Newton per meter squared. Alright. So this is the pressure in the dam. So this is how you solve this question. Alright, so let's take some Jamb questions on pressure and see how many we can solve. So the first question here says, what is the length of the liquid column in a barometer tube that would support an atmospheric pressure of 10,200 newtons per meter squared if the density of the liquid is 2,600 kilogram per meter cube? They gave gravity as 10 meters per second squared. So you have your options there. Solution. Of course, this is for a liquid. The particular liquid is not specified, so we'll still use a concept of saying that pressure is equal to density times gravity times height. Now when they say what is the length, so they actually there for what there? The length. And we said for liquids there, we consider vertical length, which of course is height. So in this case, you have to find height. Let's make h subject to the formula here. I'll have to divide here by rho g, divide here by rho g. This will cancel this. So I'll have that the height is equal to the pressure all over the product of density of the fluid and then gravity. So let's input values. H is equal to, before inputting values, observe that all the values there are in their basic unit. So pressure there is 10,200 in newton per meter squared, 10,000 in newton per meter squared. Okay, density there is 2,600 in kilogram per meter cube, so no conversion, times gravity there is 10. So let's get this done. It means that h height is equal to 10,200 all over. If I multiply this 2, it gives you 26123 000. So 1 2 3 cancels 1 2 3. So I have my h is equal to 102 divided by 26. 102 over 26. That is about 3.92 meters approximately. So let's check which option that is. That is option C, 3.92 meters. So this is how you solve this question. Alright, so let's take this other example. It says, at what depth below sea level would one experience a change of pressure equal to 1 atmosphere? Alright, so given the density of the seawater and all of those things there, let's get this done. So solution there, going straight to the point, it said at what depth? At what depth? That's the about what there, a depth or a height. So at what height? You have to look for height. Now we know that pressure is equal to rho GH. We said to get height, divide here by rho G, divide here by rho G. This cancels this. Alright? So H is equal to P all over density times gravity. By the way, this is called rho. It's a Greek symbol, rho. It's pronounced rho and represents what? Density. Just for note, it's called rho and represents density. Alright, so this is equal to, they say at what depth would, they say below the sea level would one experience a change in pressure equal to 1 atmosphere. So they said this pressure should be 1 atmosphere all over. They gave the density of the seawater as 10 to the power, is that 13? That should be equal to 3, not 13. So 3 times, that's of course density of water. That should be 3, not 13. It's 3 times gravity is 10. Alright. So this will now be equal to, so in this case you're given 1 atmosphere, check. You're given the value of 1 atmosphere in your question then as 0.01 times 10 to the power 5 all over, this is 10 to the power 3 times 10. So this is equal to 0.01 times 10 to the power 5 all over, this 2 gives you 10 to the power 4. So this is equal to, if I work this out, this becomes 0.01 times this 2, it cancels out, you have just 10. Alright, this is indices, or you can just punch directly if you want to. Punch these 2 directly, but I'm using the idea of indices, so this will cancel this one to give you just 10. But if you're not okay with this, simply punch these 2, write out your answer all over this. You still arrive here. So that's equal to multiply this by 10, that gives you 0.1. You're looking for height, that's in meter. So your answer is 0.1 meters, and that is option A. A says 0.1 meter. So this is how you solve this question. Alright, so let's look at this question. This question says I, density of the liquid, II, depth below the surface of the liquid, III, surface area of the liquid. In which of these statements above will pressure be dependent? So which of them does pressure depend on? Number 1 says density of liquid. Now what we to answer this question, then you have to look at the units of pressure, or perhaps the formulas of pressure. We just said pressure is equal to density times gravity times height or depth. Alright, height or depth, the same thing. Now, we said, in which of the following statements will the pressure be dependent on? This is pressure for liquids or for fluids. Pressure for solid, P, is equal to force over area. Now, 1 says density of the liquid. Of course, in terms of liquid, pressure depends on density. So yes, that's correct. Number 2 says depth below the surface of the liquid. Of course, that's depth below the surface of the liquid, or height. So it also depends on this. The next one there says surface area of the liquid. Okay, so it depends on density and depth. But when it comes to area is for solid. So pressure depends on the area of a solid, not a liquid. So when it comes to liquid, it depends on just density of the liquid and the height in which or the depth that the liquid occupies. So for pressure in liquid, area is not that important. So pressure does not depend on the area of the liquid. Instead, it depends on the area of what is solid, not liquid. So that means in this one here, it is just density and depth. That's just I and II. So the correct option there is C, which says I, density of the liquid, and depth below the surface of the liquid. That's II. So it's just I and II only. That's the correct answer. Alright, so let's try this question here. This question says the product PV, where P is pressure and V is volume, has the same unit as dash. You have your options there. So solution, we are given a product of P and V. We said P means pressure and V is volume. So let's get this done. P is pressure. Pressure is measured in Newton per meter squared. That's this. V is volume. Volume is measured in meter cube. So let's get their product. So P times V is equal to P is Newton per meter squared times V. Volume is meter cube. Meter squared here 1. This cancels here. Only 1 is left. So this is 2, this is 3. Alright, so if this cancels this, only meter is left. If I multiply this is equal to Newton times meter, which is Newton meter. And Newton meter is same as what there? Joules. We know that 1 Newton meter is equal to 1 joule. How? Newton is force times meter is what? Distance. Alright, so when we talk about force times distance, what comes to mind there? Work done. Alright, that's work done or work. Because it said in science, work is said to be done when a force moves an object through a distance in the direction of that force. So hence, the answer becomes work done, which is similar to joules. So the answer there is option D, work. So take a final example on pressure and alright, so the question says if a pump is capable of lifting 500 kilograms of water through a vertical height of 60 meters in 15 minutes, the power of the pump is, so you have your options there. Alright, let's get this done. So Solution. Now this one says if a pump is capable of lifting 500 kilograms, number one, I'm giving mass of pump M equal to 500 kilograms. Through a vertical height, number two, I'm giving the height of pump height H as equal to 60 meters. Number three, they said in 15 minutes. I'm giving time T as equal to 15 minutes. I'm asked to find power P equal to unknown. Alright, so first things first, what do I know? I know that power P is equal to work done all over time. Work done is equal to force times distance or height, in this case in meters, all over time. That's T. So first things first, to get force is equal to, from using second law of motion, mass times gravity. That's equal to mass 500 times gravity. Let's see if we're giving gravity as 9.8 or 10. Let's check. In this question, none was indicated, so I'm choosing to use 9.8 as gravity. Alright, so force F is equal to 500 times 9.8. We have 500 times 9.8. It's about 4,900 Newton. So it's causing a force. The height is 60. The time is in minutes. So time T equal to 15 minutes. Convert minutes to seconds. What do you have? Of course, we have to multiply by 60. That becomes 15 times 60. This is how you convert time from minutes to seconds. So 15 times 60, we have about 900 seconds. 900 seconds. So therefore, the pressure is equal to force, that's 4,900 times height, that's 60, all over time, that's 900. From there, this cancels this cancels this. Or you can just do your normal mathematical approach, whichever way you understand. So that becomes 490, this times 6, and about 2940 all over 9. So pressure P is equal to 2940 all over 9. That's about 326.67 pressure or power, please, power, not pressure, please, power, of course, is measured in watts. So I'm having this watts. So let's see our options. Okay. So if you look at our options there, from here I'm having 1, 2. So that's equal to 3 approximately. So this should be 3 from here, 1, 2. 3.26 or perhaps 27. So if I approximate to equal to 7 times 10 to the power 2 watts, that's W. But then I'm seeing approximation towards 1 decimal place. So for this now, to 1 decimal place becomes 3. So it becomes 3.3 times 10 to the power 2 watts. Of course, watt is the same thing as what there? Joules per second. The same SI unit. So this in joules per second. So joules per second and watt are dimensionally homogeneous and the same thing. So hence my answer is 3.3 times 10 to the power 2 joules per second. So the correct option there is option D. Alright, so this is as much as you can take for pressure. See you in the next class.